Hello. Hi, everyone. So, we are live now. Hi, Jashwant. So, please let me know if I am properly audible or not. Hi, hello. Okay, I am properly audible. Okay, thank you. So, we'll start with the post contest analysis of weekly coding contest 121, right? Okay, thank you. Okay, so let us start. So, let me first of all share my screen. So, I hope the screen is visible properly. Hello, hi Abhijit. Okay, so let us first of all start with question number one, that is construction of a string. So, what does this question say? It says that given two integers n and k, construct a string of length n such that it contains lowercase English alphabet characters, and each substring of length k contains at least one vowel and one consonant. Okay, so what does it basically saying is that you are given, suppose let's say n and k in the input. Okay, so you need to construct a string which contains only lowercase English alphabets. Okay, so this will contain only small a to small z. Okay, and you need to construct this string in such a way that the length of the string is n. Total there are n characters, and each k length substring, each k length substring has at least one consonant and one vowel. Okay, so let's suppose this is my string of length n. So this is the first substring of length k, this is the second substring of length k, this is the third substring of length k, this is the fourth substring of length k, this is the fifth substring of length k, this is the sixth substring of length k. Okay, so basically for all the substrings of length k, it should have at least one consonant and one vowel. Okay, so what I will do is, to be on a safer side, see, the value of k can be anything starting from 2. Okay, so what can I do simply is that for every substring of length 2, for every substring of length 2, I can place one consonant and one vowel. So how will my string look like? My string will have one consonant, one vowel, one consonant, one vowel, one consonant, one vowel, one consonant, one vowel. So if I make my string of length n such that every substring of length 2 has one consonant and one vowel, then every substring of length k will definitely have one consonant and one vowel, because k is greater than equal to 2. If all the two length substring have one consonant and one vowel, then all the k length substring will definitely have one consonant and one vowel, right? So let us take vowel as small a and let us take consonant as small b. So let's suppose my k is 3 and let's say my n is 6. So what will I do? I'll place a b a b a b until the length of the string is achieved. So I have got here 6 characters, that is the length of the string, and my k is 3. Now here every substring of length greater than equal to 2 will have one consonant and one vowel, because every substring of length 2 has one consonant and one vowel. This a and b has one consonant and one vowel, this ba has one consonant and one vowel, this a and b has one consonant and one vowel. So basically, starting with I equals to 0 and going up till n minus 1, for every index, I'll place, if the index is even, I'll place A there. If index is odd, I'll place B there. Okay. Is this clear? So let's write the code for it. So let me move this code to the editor directly. So basically I have taken a string which is empty initially, and then for I equals to 0 to n, if the index is even, then I'll take a, that is the vowel, and if the index is odd, I'll add b, that is the consonant, and I'll return my answer string, and this should work. Okay, so if I submit it, the time complexity would be big O of n, and we have solved this problem successfully. So any doubts in this? No. Okay. Okay, this code was giving TLE in Java. How can it give? Uh, I think you need. See, I'm not very much used to Java, but what I can understand is when you add. I know a little bit about Java. So when you add a character in a string, so the string concatenation cannot happen. So it will generate new string. So that's why it might be taking more time. If you take string buffer, then I think in that concatenation is allowed, and it will not take more time, right? But I hope the concept is clear. You may look at some submission which is in Java and you will get it, but I think there is some concept where in string you cannot get the concatenation, so it generates new string, so that might take more time. But if you take string buffer, that will work, right? So okay, let's move on to the next question, that is virus infection. So what does this question say? There are n people standing in a row. You are given a string s of length n, where si equals to 1 if ith person is infected with a virus, and si equals to 0 if ith person is not infected. Given k, ith person can infect up to k people on his left side and up to k people on his right side. So basically what this statement means is that ith people can infect the next k people on the right side and next k people on the left side. Okay, not any k people. Now the newly infected people can't further spread the virus. So if any person was initially not infected, so initially they was 0 but then it became 1, so they cannot spread the virus further. Find the total number of people who are infected with the virus. Okay, so at the end we need to tell how many people will be infected with the virus. So basically if we understand it, so suppose the input is 001, 001, and 00, and k given is 1. This is the first example. So wherever there is 1, that person is infected, and whenever there is 0, that person is not infected, right? So what happens is that the people who are infected can infect up to k people on the left as well as right. So this person can infect one person on the right and one person on the left. Okay, if k was 2, then this person would be able to infect these two people and this also these two people. Okay, and also understand one thing, if this is 001, 010, if k is, let's say, 2, so this person will be able to infect these two people and these two people. He cannot infect this person. Okay, so what does k equals to 2 means? That if a person is infected initially, he or she can infect the two people on the right hand side, okay, which are in the consecutive manner, if they are not infected. So for example, this is already infected, so he will not infect that person, but he can infect this person. Okay, but k equal to 2 does not mean then two number of people, any two people on the right hand side. So this or this, no, he cannot infect this person because this is the third person on the right hand side, first, second, and third. So out of the k consecutive people on the left and right, those are not infected before, you can infect them. So this person can infect this and this, so this will become 1 and 1. This person can infect this and this, so it will become 1 and 1. So the final will be 0 1 1 1 1 1 1 and 0. Now these are newly infected people. Okay, sorry, these two and this, these are newly infected people. They cannot further spread the virus, which is given there in the question. So the output for this would be 6. Okay, is this clear? Okay, is this clear? Okay. So now how can we solve it? See, the brute force method can be you loop over the complete array and or the complete string. You make a loop from, let's say, for I equals to 0 to n minus 1. You make a loop, and if s of I is equals to 1. So if a person is infected, then you make a loop from j equals to I plus 1 to I plus k, and all those which are 0 you mark them as 1, or like you need to take some other array to mark them as 1. Okay, or you can mark them as 2. Why you need to why you cannot mark them as 1? Because they cannot further spread the virus, so you need to take care of that. Okay, so let's say you mark s of j as 2 wherever s of j was 0, and you also went from j equals to I minus 1 to I minus k, and wherever s of j was 0 you made it 2. So finally wherever s of I is either 1, which is initially infected, or 2 that are after infected, you will count them. Okay, but this will take how much time? See, for every index you are making a two loops of size k, so total time complexity would be n into k. This will take a lot of time. Are you getting my point? So this will give you time limit exceeded, so you need to think of something better. Okay, now understand one thing. Suppose you are given 1 0 0 1 0 1 0 0 0. Okay, and let's say what is the length of this 1 2 3 4 5 6 7 8 and 9. Suppose k equals to 8. Okay, so this person can infect all these 8 people, this person can infect all these people, and this person can also infect all these people, right? So suppose this person will get infected. Okay, so he can also get infected by this, he can also get infected by this, and he can also get infected by this person, because all of them are in the range. But if I keep a mark for every index I, if I keep a mark that who on the left hand side, who on the left hand side of I, left hand side of I means who among the indexes from 0 to I minus 1 is closest to I on the left hand side and is infected. So for example, for this index, I only need to keep the mark of this index that this person is infected. I do not need to keep mark of this and this. Why? Because if this person can infect this person, then definitely this person can infect this person. Are you getting my point? Because this person is closer to this. So if this first person can infect the last person, then this person can definitely infect this person, right? So what I am trying to say is, for every index, if you keep a mark of the nearest left element which is infected and just calculate the distance between them. So just calculate the distance between the ith index and the nearest left hand side index j, where s of j was initially 1. Okay, so this is the nearest to I. So if the distance between I and j, that is I minus j, is less than equal to k, then ith person will get infected, otherwise ith person will not get infected. Because if j is the nearest left hand side element, and if j cannot infect I, then other can definitely not infect I. So suppose let's say for this question, okay, 1 0 0 1 0 1 0 0 0. Suppose my k is 2. So for this person, either this can infect or this can infect. The nearest person on the left hand side is this one. Now this cannot infect this person, so definitely these two also cannot infect because they are even farther. Okay, so what I'm trying to say is we just need to keep a mark of nearest left hand side element for every index who is infected and then calculate the distance. Okay, this we can do it in big O of n time, and we will do the same thing for all the indexes I on the right hand side elements also. So which element on the right hand side is nearest and which is infected? Suppose j is the index which is on the right hand side of I and it is the nearest to I and it is infected. So I can say if j minus I is less than equal to k, then ith person will get infected, otherwise he will not get infected. Is this much clear? Is this much clear? Hello. Can you show by dry run? Okay. So let's dry run on this example only. Okay. So let's say 10010101000. Okay. So what I'll do is I'll move from left to right and I'll take a variable last. It means that which was the last index which was infected. Okay. Which was the last index which we found which was infected. Initially I'll take last equals to -1. Okay. So I'll start moving from here. So this person is infected, so my last will become what? 0, because this is 0 index, 1 index, 2 index, 3 index, 4 index, 5, 6, 7 and 8, and this person is infected, so my answer will become 1. Okay, now I'll move to this index. Now this person is not infected, so I'll see whether the distance between this person and the last infected person is less than equal to k. Suppose my k is 2, so at present I am at index 1. 1 minus last infected person is less than equal to k or not. Last infected person was 0. Last means which we found last during the for loop. So is this less than equal to 2? Yes. So this person can also be infected. So what I'll do, I'll mark answer as +1. But will I change my last variable? No. Why? Because one was not initially infected. One got the virus after spreading it from 0, and those who were not initially infected cannot further spread the virus. Okay, so I'll not change my last variable, I'll just add 1 to my answer. Then my I will become 2. So is 2 minus last less than equal to 2? Yes. So again I'll add +1 to my answer. Then I'll come to I equals to 3. Is 3 so 3 is infected initially only, so I'll do +1, and now my last variable will change because 3 was initially infected. So now my last will become 3. That is, third index is the last index which we encountered as infected. Okay, so now when I'll go to I equals to 4, what I'll do is 4 minus last infected less than equal to k or not. Now what is last? It is index 3. 3 was the last encountered index which was infected. Is this less than equal to 2? Yes. So 4 can also be infected. So I'll do +1. Okay. Similarly, I'll go to 5, 6 and 7. All these will be infected. So my answer will basically become 8. Okay. And when I'll be at index 8, my last variable will contain what? 5, because 5 index is the last index which we encountered as infected. Now I am at index 8. So I'll check whether 8 minus 5 is less than equal to k. 8 minus 5 is 3, is less than equal to 2? No. Since 3 minus 2, 3 is not less than equal to 2, so 8th index cannot be infected. Understand, last is equals to 5. 5 is the nearest element on the left hand side of 8 which was initially infected. If 5 cannot infect 8, then 3 and 0 can definitely not infect 8, because the distance between 3 and 8 and 0 and 8 is even more, right? So if 5 cannot infect 8, 3 and 0 can definitely not infect 8. Is this much clear? Rohit, is this clear? Okay, so now let's look at its implementation. Also, we'll do the same thing from moving from right to left, because the infection can spread in both direction. Okay, so suppose I have 0 0 1 0 and my k is 2. So this person can infect this and this also. So for that I need to move a loop in this direction and maintain last variable as it is. Okay, so let's look at the implementation. So what I have done is I have taken answer equals to 0 initially, last as -1, n as the size of the string, and 1 I to iterate. Then I have taken count of size n. So what that basically does is, whenever n person is counted as infected, I'll mark it as 1. Now why I need to mark it as 1? Because it might be possible that a person is infected from both sides, left side and right side, but I cannot count two for one person. One person I can count only one. Okay, are you getting my point? So for example, suppose I have a string 101 and k is 1. So even this can infect this and even this can infect this. So while moving from left to right, I'll mark this as infected. While moving from left to right, if I again count this as infected, then I'll count this twice, which is not proper. Every person should be counted only once if they are infected. Okay, so for that I have used count variables. Now I'll move from left to right. So for I equals to 0, I is less than n, I plus plus. If a person is infected, first increment the count of the answer variable, change the last variable. Now last will become I, and make count of I as 1. Okay, else if the person is not 1, so I'll check whether, so if last is not equal to -1, now what does last represent? Last represents the last encountered infected person. So if it is equal to -1, it means we have not encountered anyone till now who is infected. So if it is not equal to -1, I'll check whether the distance between I and last is less than equal to k. If so, then ith person can also be infected. So I'll increment the answer counter and make the count of I as 1. Okay, now I'll start moving from right to left direction. Again, I'll make the last variable as -1, make a for loop from n minus 1 to 0. If a person is infected, if count of I equals to 0, then only increment my answer. But it would not be possible, because whenever we found a person to be infected, we marked this count of I as 1. So one person is not counted twice while moving from right to left and left to right. Okay, but you need to change the last variable. So last encountered person will become I in line 44. Else, if the current person is not infected initially, if last is not equal to -1, so I'll check if the distance between last and the current index I is less than equal to k. If it is less than equal to k, then the ith index person can be infected by the person at the index last. But for that, I also need to check if count of I is equals to 0, because it might be possible that a person was infected, was counted as infected when we moved from left to right. So if count of I is 0, it means it is not counted before, then only increment the answer. Here we will require only 2 for loops, because while moving from left to right and right to left, we maintain the index of the last infected person. Okay, and finally we will return the answer. So is this clear? Please explain right side by dry run. So it will be same as left side. Okay, so basically see here, 1 0 0, let's say 1. Okay, so what will happen is, let's say we are running only from right to left. Okay, we have not run from left to right. That is what I'm telling. Okay, or let's say we have also counted from left to right. Okay, so let me take 1 0 0 0 and 1. Okay, and k is 2. So when we move from left to right, these two persons will get infected by this. So I'll mark their count variable as 1, and this count variable will also be 1. But this person will not be infected, so this person's count would be 0. Now when I'll move from year to year, when I'll be at this index, my last would be what? Last would be equal to 4, because this is 0 index, first index, second index, third index, and fourth index. And here I encountered a person who was infected. So this is index 3. So I'll see whether 4 minus 3 is less than equal to k, that is 2. This is true. So this person can also be infected, and I'll increment my answer counter. Why? Because its count was 0. So it was not considered while moving from left to right. Now for this person, this can also be infected, right? Because this is at second index. So 4 minus 2 is also less than equal to 2. But we will not consider this because its count is 1. It was already counted when we moved from left to right. So this is the count array, and this is my string s. Okay. What is the reason behind doing from right to left? So see here, one person who is infected can infect persons on the left hand side as well as on the right hand side. Okay, so let us consider this case 1001, and my k is 1. So when I run from left to right, I'll say that this person can infect this. Okay, but this person will not be counted as infected, because on the left hand side of it, the nearest is here at a distance 2. So that cannot infect this person. But if I move from right to left, I can see that this person can infect this, because the distance between them is 1. So to consider all the cases, we need to move from left to right as well as from right to left. Okay, so this is my code. Okay, someone is asking to share the code. So I have made first count of I equals to 0. Then I have moved from left to right, and whenever a person is infected, s of I is 1. Increment the answer counter, change the last variable, and make the count of I as 1. Otherwise, check if I minus last is less than equal to k, then increment the answer and make count array as 1. Then make a loop from right to left and see the similar things. Would you provide link to this solution? Okay. So I have added the link in the comments. Okay, you can get the solution code from here. The time complexity would be big O of n, because we are using, if they are consecutive ones, then are we updating the count of n as 1? Yes, because basically what count of I denotes that while moving from left to right, if that person was getting infected, we had counted. Okay, so if that person is again getting infected while moving from right to left, we do not count the same person twice. Okay, so that's the only reason. Okay, is this clear? Shall we move further? Okay. Okay. So let's move further. Let's move on to the third question, that is maximum removals. What does this question say? It says that there are n houses on the geek street where the population of the ith house is given by a of I. Okay. Okay. So there are n houses in a street where the population of the ith house is given by a of I, right? Let there are m distinct subsequences of houses whose sum of population adds up to x. So what does that mean? We will be given x in the input, and depending upon our array there are m number of subsequences, okay, whose sum of population, that is, let's say a subsequence has ai plus aj plus some number of elements of the array would be there. The sum of the population is equal to x, and number of such subsequences are m. Okay, let's suppose two subsequences are different if there is at least one house which is not common in one of the both sequences. Okay, geek wants to remove maximum number of houses such that the number of distinct subsequences of houses whose sum of population adds up to x remains the same, that is m. Find the maximum number of houses geek can remove. So now what the question says is, from this n houses, geek wants to remove some of the houses. Okay, and he wants to remove as max as possible number of houses. But the condition is that after removing the houses, the number of subsequences whose sum of population is equal to x remains the same, that is m. Okay, so if we look at the example, so n is 6, x is 4. So n is 6, x is 4, and the elements are 1, 3, 2, 3, 4, 5. Elements are 1, 3, 2, 3, 4, 5. Okay, so there are 6 houses and the population in each house is given by 1, 3, 2, 3, 4, and 5. Okay, now x is 4. So first of all, let us find the number of subsequences whose sum of population equals to 4. So one subsequence is 1, 3, this one and this 3. Another subsequence is 1 and 3, this one and this 3. These both are different subsequences. Okay, because the definition of different subsequences is that if there is one house which is there in one subsequence and not there in another subsequence, then those are considered different. So this house was considered in this subsequence but not in this subsequence. This is not considered here. So these two are different subsequences. What can be the other way? You can add 4 and 2. Sorry, you can add 1 and 3. 1 and 3 you can simply take 4. So you can make 3 subsequences whose sum of the population is equal to 4. Okay, now geek wants to remove the sum, as max as possible number of houses, but the number of subsequences whose sum of population is equal to x should remain the same. So now which houses can you remove? Can you remove one? No, because then the number of subsequences will reduce, because one is used here as well as here. Can you remove 3? No, because 3 is used here. Can you remove this 3? No, because 3 is used here. If you remove them, then the number of subsequences whose sum is equal to x will reduce. Can you remove 4? No, then also the number of subsequences whose sum equals to x will reduce. You can only remove those elements which are not part of any subsequences. So 2 is not part of any subsequence whose sum is equals to 4, and 5 is not part of any subsequence whose sum is equals to 4. So if you remove 2 and 5, it will not affect the number of subsequences whose sum is equals to x, that is 4. So you can remove 2 and 5. So the maximum number of houses which you can remove is 2. So your answer will be 2. Is this much clear? Okay. 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 So now how can we implement this? See, understand one thing. In in dynamic programming, there is one question that is subset sum problem, right? That basically denotes, can you does there exist a subset whose sum is equal to the given sum. Let's say the given sum is p, so we need to tell whether there is a subset equal to the given sum. Here subset and subsequence will be equal. Why? Because subsequence is same as subset. The only condition which subsequence requires is that the order of elements should be same as the original array, otherwise it is same as subset. But in subsequence, here we need to count the sum of elements is equal to x or not, right? So the order of elements does not matter. So can we say it is subset only? Okay. So there is a problem, that subset sum problem, which basically says, does there exist a subset in the given array whose sum is equal to the given sum? So this is the target sum which is given in the question. Now we are said that we need to find maximum number of houses which we can remove, even after which the sum of the elements or the sum of the subsets whose sum is equal to x will remain the same. Okay. So now what we can do is, see, understand one thing. Suppose I have one element as 3, okay, and I want to find the number of subsets whose sum is equals to 5. Okay, I want to find the number of subsets whose sum is equals to 5. I know the number of subsets whose sum is equals to 2. So the number of subsets, and also which should include this 3. I want to find the number of subsets whose sum is equals to 5, and they should also include this 3. So the number of subsets whose sum is equals to 5 and should also include this 3 is nothing but the number of subsets whose sum is equals to 2. Because if there are, let's say, 4 number of subsets whose sum is 2, in each of these subset I can consider this 3, and each of the 4 subsets will get converted to sum equals to 5. Okay. So now what we can do here is, we need that the number of subsequences or subsets whose sum is equals to x should remain the same. So if I do not consider the ith element, and if my number of subsets whose sum is equal to x minus a of I is 0, it means that the ith element does not contribute in any of the subsequences. Understand this. Suppose there are 4 subsets whose sum is equals to 2, okay, and I want the subset sum equals to 5, and I want to include an element 3 which is there in the array. So the number of such subsets will also be 4, because in each of these subsets I'll add plus 3 in each of the subset which has 2. Okay, so I'll add plus 3 and the sum will become 5. Now what I'm telling is, if I do not consider the 3, this is the ith element, and if I get the number of subsets whose sum is equals to x minus a of I. Now what is x? The target sum. The target sum here was 5. So 5 minus 3 is equals to 2. So if I get the number of subsets whose sum is equals to 2 is 0, then I can say there are no subsets or subsequences which has a of I and whose sum is equal to x, because here the number of subsets whose sum is 2 are how much? 4. That means that this 3 was a part of 4 subsets whose sum was equal to the target sum 5. But suppose there are 0 subsets whose sum is equals to 2 if I do not consider the element 3. So if the number of subsets, the number of subsets while considering 3 whose sum will be equal to 5 will also be 0, because there are 0 subsets whose sum is equals to 2. So even if I add 3 to all the subsets, but there are no subsets whose sum is equals to 2. Are you getting my point? We write in dp that dp of sum considering the ith element is equals to dp of sum initially, or let's say what we write, dp of ij, this is 2D array, okay, is equals to dp of I minus 1j plus dp of I minus 1 and j minus a of I. Okay, what does this mean? Number of subsets considering the first I elements whose sum is j is equals to number of subsets considering the first I minus 1 elements whose sum is j if we do not consider the ith element, and number of subsets whose sum is equals number of subsets considering the first I minus 1 elements whose sum is j minus a of I if we consider the ith element, right? So that is what I'm trying to explain here. If there are zero subsets whose sum is equals to 2, then how many subsets will be there which has ith element, that is 3, whose sum will be equal to 5? Zero, because there are no subsets with sum 2. Then I cannot add 3 and get 5 in any of the subsets. So what I can do is, if the number of subsets whose sum is number of subsets of sum x minus a of I is 0, if we do not consider the ith element in our array, okay, if we do not consider this, if the sum is this 0, it means that considering the ith element there are no subsets whose sum is equal to x. Otherwise there are, like in the initial example we said that there are 4 subsets whose sum is equals to 2. Now I want to add 3 and get 5 as the target sum. So if I add 3 in all these 4 subsets, I'll get 4 subsets whose sum will be equal to 5, right? So now if I do not consider this 3, and if I ask you the number of subsets whose sum is equals to x minus a of I, that is 5 minus 3, that is 2, that is equals to 4, it means that if the number of subsets whose sum is equal to x minus a of I, that is 2, is equals to 4, it means that considering the ith element also I will get 4 subsets whose sum is equals to x, that is the target element. So I need to consider that only. If I do not consider the ith element, whether the number of subsets whose sum is equal to x minus a of I, whether it is equal to 0, then ith element will not be a part of any subset whose sum will be equal to x. Is this much clear? Okay. Shall we move on to the implementation? Can't we do like count of number of subsets whose sum is equals to x and n minus count? No, n is the size of the array. Count is the number of subsets whose sum is equal to x. Your array size may be 5 and the number of subsets whose sum is equal to x may be 16. So 5 minus 16 will give you minus 11. Okay, you are subtracting the size of the array from the number of subsets. That is not like kind of uh, valid only, right? So let's look at the implementation also, like during the subset sum problem we can also use a 2D array, but here the size of the constraints are such that we need to do an optimized approach. Okay, so what I have done is I have taken s is equals to n plus 1 cross 100. Why? Because this is the maximum sum of any subset. Why? Because n is the size of the array input, so n are the total number of elements, and the maximum value of any element can be 100. So the total sum of all the elements is n into 100. So I have taken n plus 1 star 100, okay, and I have declared a dp array of that size. Then I have taken variables I and j. I have taken mod equals to 10 to the power 9 plus 7, which you will understand in further time. I have taken two variables, so sum and answer is 0. Okay. Okay, so someone is saying, can you please explain with answer? So what we will do is, I'll write some of the extra code in the given sample so that you can see the output and understand. Okay, because doing a dry run and explaining, like doing a lot of dry run, it will break in between. Okay, better would be we would add some of the code in this so that we get the explanation of what's happening at each step. Okay. Sir, when a GFG reward come in stock, just waiting for 2 weeks. Okay, I'm not sure about this, but I'll I'll tell the management about your concern. Okay. So basically, DP of I will contain what number of subsets whose sum is equals to I. Okay. So initially I have initialized dp of I equals to 0 for all, and I have initialized dp of 0 equals to 1. Why? Because the number of subsets whose sum is 0 is always 1. That is an empty set. Okay. Then I have moved from all the elements from I equals to 0 to n, and if a particular element is less than equal to x, then only I am considering it. Because if a particular element is greater than x, then there is no need of considering it. Like if my x is 10 and if the number of population in one house is 12, then there is no need of considering its contribution. Okay. Or we can also remove that, like because we also want to dry run, right? So let's remove it. Okay, just calculate the number of subsets. Okay. uh, Here we will keep it as it is. Okay, we'll understand that later. Okay, so here what I have done is, I have first of all calculated the number of subsets whose sum is equal to I. Okay, in dp of I. Now how I have calculated it? So I have looped over all the elements for I equals to 0 to n, and I have looped in the reverse for j equals to sum, j is greater than equal to 0, j minus minus. And sum is what? Sum is the highest limit of sum which we have achieved till now. Okay, so sum is highest value which we have achieved till now, so that we do not have to loop again over the whole sum. Okay, so j equals to sum, initially sum was initialized to 0 because empty subset is equals to 0. Okay, so what I did was, didn't get the exact approach of what you are trying to say right now. Okay, so I'll explain that once more. Okay, don't worry. And I will also dry run on this so you'll get a better idea. So sum is basically the highest sum which we have achieved till now. Now understand this: if I want to include the ith element, then suppose j is the, so j varies from sum to 0. So from 0 to sum I have got the sum till now of some of the elements. Okay, so suppose my, as I said here, if my dp of 2 is, let's say, 4, and if I add 3 to all those 4 subsets, I can get, see, understand this. Suppose my dp of 2 is 4, it means there are 4 subsets whose sum is equals to 2. Okay, till now. So, and the current element is 3. So, can I say dp of 3 plus 2 is equals to dp of 3 plus 2 plus dp of 2? Because suppose let's say this was initially equal to 0 and dp of 2 is 4, then dp of 5 will also become 4, because if there are 4 subsets whose sum is equals to 2, and if I consider adding the element 3, I can add 3 to all these subset whose value is 2, so the number of subsets whose sum is equals to 5 will also become 4, right? So that is what I am trying to do here. Dp of j plus a of I is equals to dp of j plus a of I plus dp of j. and j is one of the values of the sums which we have achieved till now. That is, it lies between 0 and sum, and sum equals to max of sum comma j plus a of I. So if we have reached the bigger sum, then we will update its value. So now let me just write here, for I equals to 1, I is less than equal to sum I plus plus COUT dp of I. Okay. So let me run this. So basically what does this say? Suppose this is your array. Okay. Let me zoom it. Okay. I hope now it's visible. So suppose this is your array 1, 3, 2, 3, 4, 5. So this basically denotes how many subsets are there whose sum is equals to 1. There is only one subset, that is 1. How many subsets are there whose sum is equals to 2? There is only one subset, that is 2. How many subsets are there whose sum is equals to 3? There are 3 subsets. The first 3, the second 3, and 1 and 2 combined. How many subsets are there whose sum is equals to 4? There are 3 subsets. 1 and the first 3, 1 and the second 3, and the 4 itself. How many subsets are there whose sum is equals to 5? There are 4 subsets. 1 and 4, 3 and 2, 3 and 2, and the 5 itself. Okay. How many subsets are there whose sum is equals to 6? There are 5 subsets. 1 and 5, 4 and 2, 3 and 3. Then what are the other two? 1, 3, 2, and 1, 2, 3. So there are 5 subsets whose sum is equals to 6. So basically in dp of I have got the number of subsets whose sum is equals to I. Is this much clear? Is this clear? Hello? Is this much clear? So we'll move further. Is it one based you are following? So the indexes are definitely zero based, but what I'm trying to do is, if I am in dp of I am storing the number of subsets whose sum is equals to I. That's why I ran the loop from I equals to 1 to sum. For sum, yes, I am using one based index, like I equals to 5 represents number of subsets whose sum is equals to 5. Okay. So now we have got the number of subsets whose sum is equals to I. Okay. Now see, let me explain this once more. Okay. Some people had doubt. Suppose you have 4 subsets whose sum is equals to 2. Now you want to include the element 3, and you want to find the number of subsets whose sum is equals to 5. This is the target sum. So can I say the number of subsets whose sum is equals to 5, including these 3, is also 4, because there are 4 subsets whose sum is equals to 2. So in each of these 4 subsets, what I can do is I can add these 3. So I'll get 5 here as the sum, because their initial sum was 2. So the number of subsets whose sum is equals to 5, considering these 3, is same as number of subsets whose sum was 2, not considering these 3. Are you getting my point? number of subsets whose sum is equals to 5 considering this subset 3 is same as number of subsets whose sum is 2 not considering this 3. So if so, can I also say number of subsets whose sum is equals to x is same as considering the ith element is same as number of subsets whose sum is equal to x minus a of I, not considering the ith element, right? So now what I'll do is in the dp array I have got dp of I as the number of subsets whose sum is equals to I. Now one by one I'll try to nullify the effect of the ith index. Suppose ith index is not present, what effect it will make on the number of subsets whose sum is equal to so and so. So I'll nullify that effect. Then I'll see the change in the sum and I'll see whether the number of subsets whose sum is equal to x minus a of I, if I do not consider the ith element is 0, it means that number of subsets whose sum is equal to x, if I consider the ith element, is also 0. So ith element is not a part of any subset or subsequence whose sum is equals to x. So I can remove ith element. So I'll do answer plus plus. If after not considering the ith element, if the number of subsets whose sum is equals to x minus a of I is greater than 0, it means that there are subsets whose sum is equals to x. There are the number of subsets whose sum is equal to x considering the ith element is also greater than 0. So x element is, so the ith element is part of one of the subsequences or subset whose sum is equal to x. So we cannot remove the ith element. Okay. So now we have tried to nullify that effect. So how we will do that? So look here. So what I have done here is for I equals to 0 to n, I'll try to nullify the effect of the ith element. But understand one thing. If the ith element is less than equal to x, then only it makes sense to nullify that and counts its effect. Because if the ith element is greater than x, then anyways it cannot contribute to any of the subset whose sum equal to x. If my x is 8 and if a of I is 20, then there is no subset whose sum is equal to 8 and 20 is one of its value. So if a of I is greater than x, then I can remove that element. It is of no use. So I'll directly do answer plus plus. If that is less than equal to x, I'll try to nullify that effect. So what I'll do is I'll decrement the count of the sum values starting from a of I and maximum going up to sum. Right? Why? Because see, those values of sum whose sum is less than a of I, now like j equals to 10 and a of I is 12, then that 12 cannot be a part of sum whose subset whose sum is 10. So the subsets which I need to consider will start from a of I, because if a of I is a part of that subset, its sum will be at least a of I, and I'll go up till sum. And what I'll say, dp of j is equals to dp of j minus dp of a of dp of j minus a of I plus mod modulo mod. Okay. Now let us first discuss why we require this to apply mod, because here the value of n is going up till 1000. I think the value of n is going up till 500, so the number of subsets can go up till 2 ki power 500, which is very 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 large value, and we cannot store it in any of the integer types, right? So what we are doing is at every step we are taking modulo mod, because anyways we do not want the number of subsets exactly, we just want whether an element can be removed or not. So this will nullify the effect. Now let me write the values of the sums here. Okay, so let's take j equals to 1, j is less than equal to sum j plus plus count dp of I. Okay, and let me put two new lines here. Okay, and let me compile and run it. I think I need to put a new line here also. Okay, so what we have, output is too large to display. What is the value of n? I think we have done something wrong, or so j. Acha, I am writing here I. It should be j. Okay, okay. Okay, so this is what we are getting. Now understand one thing. This was the initial number of subsets whose sum equals to the given sum. Now if I do not consider the first element, okay, that is 1, then the number of subsets, okay, let me zoom it. Okay, so now look here, this was the number of subsets for a given sum initially. Now if I do not consider the first element, then the number of subsets whose sum equals to given sum changes in this way. What does that denote? If you do not consider the first element 1, then the number of subsets whose sum equals to 1 becomes 0, obviously, right? The number of subset whose sum equals to 2 becomes 1. Why? Because it was also 1, now also it is 1, because there was only one subset 2. This is number of subset whose sum equals to 3, that becomes 2 if we do not consider the first element. Why? Because initially there were 3 subsets, first 3, another 3, and 1 and 2 combined. But if I do not consider 1, then the number of subset whose sum equals to 3 decreases by 1, so it became 2. This is number of subsets whose sum equals to 4 if I do not consider this first element, that is equal to 1. It was 3 initially. How it was 3 initially? 1 and 3, 1 and 3, and 4. There were 3 subsets. Then it became only 1, that is the 4 itself. Why? Because if I do not consider 1, then 1 and 3, 1 and 3, these two subsets whose sum equals to 4 will go away. So in that way, these are the number of subset whose sum equals to I if I do not consider the first element. These are the number of subsets whose sum equals to I if I do not consider the second element. These are the number of subsets of sum equals to I if I do not consider the third element, and so on. Okay. Now let's come back. So this will represent that. Okay. So let me comment it out. Okay. Now, as I explained here, that if I do not consider the ith element and the number of subset whose sum is x minus a of I is 0, it means there were no subset considering the ith element whose sum was equal to x, right? So if after not considering the ith element, I have updated the dp array from line 45 to 48, if dp of x minus a of I becomes equals to 0, it means there are no subsets whose sum equals to x minus a of I not considering the ith element. It means there are no subset whose sum equals to x considering the ith element. It means ith element is not a part of any subset whose sum equal to x. So I can remove the ith element and I'll make answer plus plus. Now, before moving on to the next element, that is I plus 1, the effect which I nullified due to the ith element, I need to reconsider it back, because at a time I am only not considering one element. So I'll run a loop from j equals to sum to a of I, and I'll say dp of j equals to dp of j plus dp of j minus a of I. I'll again consider back the ith element. Then I'll go back to the next loop, not consider the ith element, and again check for the same things. Okay. Also understand why we require mod, because we do not want the number of subsets exactly. We only want if the number of subset becomes equal to 0. Now if the number of subsets become equal to 0, then even if you apply mod, 0 will remain 0 only. Like mod will change the original value of which element? The elements whose values are very large, but we do not want the exact value of them. We only want number of subset if a subset becomes 0 after not considering the ith element. Okay, so in that case we'll do answer plus plus and we'll consider the ith element back and move on to I plus 1th element. So let me comment out this also, and let me compile and run. Let me submit it. And we have solved this problem successfully. Okay, any doubt in this? Now tell me. Any doubts? Did you understood what we are trying to do? So basically we count the number of subsets whose sum equals to I, considering all the elements. Then one by one we nullified the effect of the ith element and count the number of subset whose sum was equal to x minus a of I. If that was equal to 0, we said that there are no subset whose sum equal to x, considering the ith element, which has ith element included. So I did answer plus plus, okay, whenever we encountered such thing. Is this clear? Please let me know. Hello, am I audible? I hope so. You want the link to the code of for this program also? Then I'll share it. Okay, let me share the code. Any doubts, please ask me. Okay, no doubts. Then shall we end the session here? Hello. Hello. Why no one is replying? Please tell me. Okay, so let's wait for 1 minute more. If there are no doubts, then we'll end the session here. Okay. Okay, so we'll end the session here. Thank you for joining. Have a good day.